I can breathe again. I think is
Yeah, that's true. That's true. That was very stressful.
yeah, the basic outcome. So yeah, Mitsu, listen, thank you very much for joining us this afternoon. And Mitsu Edwards is an engineer, structural engineer, of course, and she is working in Paris for most of her career. But she's trained in the UK, and I think you know. I suppose it's really interesting, Mitsu, to have you talk in particular about your work with artists, but I did also want to say a little bit about your work with architects, which is in fact probably the day job, or at least
It,
maybe part of the day job. I don't know. Certainly, that's been our experience. And but I think that Mitsu's been working as an engineer, working with architects mainly on facades and very large, very complex facade systems, which I think part of the the reality of a facade is that it's the most kind of public part of the outside of a building for sure, but also one of the most kind of critical aspects of a building in terms of its environmental functioning. So kind of shifting and working with artists, and particularly very well-known artists in very in a very public sphere and in the public realm, is work that I suppose from an engineering perspective is a little bit unusual. Mitsu, I think it's fair to say that some of the work that you've been doing is really extraordinary, and we thank you very much for joining us, and look forward to having you share with us some of that experience, and maybe we can come back and have a few questions when you're done. So thanks very much indeed.
okay, so let me try and connect my screen. Haha. All right.
Perfect.
So we're on. First of all, what I should say is it's been an awful lot of fun working on these sculptures, and I'm very lucky to have been able to have this experience, which just happened kind of by accident. And I guess accidents, you have to take the chances when they arrive and then turn them into something bigger along the way. And that's really how I ended up having these different experiences under my belt. But I wanted to start off with a little, as I understand I'm speaking mostly to architects in the making, that I've been quite struck by the similarities, but also the differences between architects and artists when we're working together, because artists are obviously, sorry, I apologize, I'm a little bit hesitant on this. Both have highly creative and searching souls, and both have a need to imbue their work with meaning, of course, and both have a huge amount of tenacity. You all need an awful lot of tenacity in order to get your projects built. But whereas architects have to navigate through the constraints of their client's brief, and budget caps, and building standards and regulations, and the technical needs of their engineering consultants like me, artists can generally pretty much create whatever art they choose. And I thought this was a wonderful picture illustrating whatever art you choose. This is Jeff Koons at the Rockefeller Center. And also, although architects, both artists and architects love making things, architects mostly operate as skilled delegators, and they have to draw and describe their work, and you guys have to do that so that they can be constructed by other people. Whereas artists are very much hands-on inventors and builders and testers, and this is Marc de Souverain like welding his own structures himself. So health and safety issues, when you're working in your own domain, you can choose to accept or ignore, as in this case. This was a few years ago, to be fair. Also, architects have the comfort of regular payment during the design development according to pre-agreed fee scales. This is Ranchon, but Corbusier was nevertheless paid all the way along. But artists very often have to fund their own exploration and research by themselves in the hope that they'll find a gallery or a collector who's prepared to purchase what they've created at some later stage. So this project here is Frank Steller's bandshell, which is a very large sculpture for Miami, which he self-funded to sell later. And it was, I mean, Frank Steller has the wherewithal, but You know, this was over $1 million of self-funding here. And artists have to really believe in their own work and really self-promote and be their own entrepreneur in lots of ways, in a way that an architect is spared from that role often. So there's a very strong emotion in artworks and a single-minded focus. So I'd like to talk about my first encounter with a real artist. Was Marc de Souvreau. That was in 1997, so quite a long time ago, when the city of Paris invited him to exhibit 9 large-scale works throughout the city. This was at the Esplanade des Invalides, and there were these 4 sculptures had already been built, so there wasn't any health and safety issue or safety for the public issue. But 2 of the projects, these 2 here, were called E = MC² on the left and Grâce à Toi on the right. These 2 he was building specially for the exhibition. And the one on the left was 30 meters high. He'd already built it. And the one on the right was only 12 meters high, but as you can see, quite fragile sculptures, although the basic stability was not in doubt. You know, 4 legs, and it's not balancing precariously. Nevertheless, quite lightweight elements. The foundations needed to be checked, because the one on the right was sitting on a wooden parvis at the Bibliothèque Nationale. The one on the left is in front of the public parvis in front of La Villette, and the city of Paris at the last minute got cold feet and said, you know, we need some calculation notes to ensure that these new works are safe, because they haven't been proved before. So I went through all the process. This landed, you know, just by chance on my desk, and I went through all the sort of due diligence of checking all the assemblies, checking the welding, etc. And I came to the conclusion that everything was fine except for the with the temporary foundation plaques at the bottom. That was all sized correctly, but that Marc hadn't welded quite so far enough up on the upper elements of E = MC². And at that time, I just assumed that an atelier had done all the welding. And so I said, well, the weld lengths need to be extended. And this is another view from down below. The E = MC² is like 30 meters high. So it's a 9-story high building. So what I didn't realize was that the results of my calculations meant that Marc himself would go up at Coeur de Lion and weld the sculpture, the extensions to the sculpture according to my instructions. So that was rather humbling in a way, that the artist went right up to act on my words immediately. And also it was a reminder that it's incredibly important for a sculptor to be hands-on. They don't like to delegate. They like to be in direct contact with the material themselves and take charge of everything to do with the with the creation of the form, as far as is reasonably possible. So that was 25 years ago. The sculpture has now been moved to Storm King Park in Sculpture Park in upstate New York, and Marc's welding is still holding good. So it was a really important lesson for me also, in that, but although sculptures are often designed as temporary installations on a given site, they can then be transferred subsequently to many different sites. And when you're doing the calculations to justify them, you have to bear in mind that the wind loads for this one site may easily be exceeded in another site. The foundation conditions may not be the same, and you have to build in flexibility into your engineering design approach for these elements. So that was my very first foray into the world of artists. And then my most recent work is the opposite extremes with Susanna Fritscher, and her work is all about lightness. It's the other extreme of the architectural scale, lightness and fragility. And she likes to invest a whole volume, architectural volume, with her sculptures. So the first piece we worked on together was the Musée des Arts in Nantes. And here you see the finished work. It's basically a rain of silicone threads going up to this light well ceiling, which is 15 meters high again. The space is 25 meters square. And the idea was to hide the sculpture, hide the supporting elements for the threads, make them appear to be part of the architectural volume and not part of the sculpture. You can just about see them. I don't know if you can see my mouse, but you can see the structural elements here that were hanging the threads, and then these are weights along the bottom, creating the crisscross on the floor, which are keeping the threads in place, keeping the geometrical rigor of the composition. So, and the idea was you create this mist inside the space that is quite mysterious. You can walk through it, but you don't know how you can walk through it until you actually get into the space. The challenge was, of course, then how to suspend these top rails. The building itself was a 19th century building, which was being renovated by Stanton Williams. And I'd worked previously with Stanton Williams on the structure and facades of the renovation, and that's how I'd met Susanna in the first place, because Patrick Richard, the architect of the renovation, was very interested in working with Susanna, tried to get her involved in a permanent part of the building, didn't work out. So then she was invited to do the inaugural exhibition for the opening, and that's how I ended up back in the loop again. So the tricky thing was it was a 19th century structure. The rails that we needed to hang the threads from were arranged at 4.5 meter centers in parallel to the arcade down at the bottom. But of course, if you see on the right hand side of the sorry, can you see my can you see all my how do I get rid of that? Don't know how to get rid of them. Masky living it to video. That's better. So you can see that the actual structure, grid work of the structure from which we could hang the 19th century was not aligned with the arcades. So we had to have some quite long cantilevers, like 6.5 meter cantilevers, which you can see on the right hand side here. And we thought everything, we sized all that, thought everything was fine. And then the checking authority came back and said, unfortunately, there's been a mistake in the sort of allowances made in the 19th century structure that was checked by Bouygues at the time. They were supposed to allow for a weight hanging of 1.5 kilonewtons at regular intervals through this roof, and they only allowed for 1.5 kilonewton weight at one position in the roof. So we're like, oh, that's a bit tricky. We got to redistribute that. So we had to go into the huddle with the Bureau de Control and, the checking authority, and spent 2 days, it was over a weekend. We didn't speak to anybody else. We didn't let the artists know that this major problem had just occurred in justifying the structure. And we managed to justify the 19th century structure for the increased loads that we were applying on the framework, and everything continued apace. Of course, at the time that this bombshell struck, the rails were already built, the threads were being threaded by Susanna. This was the method that she used to connect the threads. Every 8 millimeters is a silicon thread threaded into a sort of cone-like structure at the top, and we designed this a paired T section to clamp the threads in. So very simple structurally, but it had to be as discreet as possible. And that's Susanna threading. Susanna's in black at the end of the table. So she, again, very hands-on, participating in the threading of like kilometers and kilometers of these threads, very painstakingly, in order to deliver them to the site and then hang them. And another interesting thing that we had to do for her was, you see the rails are curved here. She wanted the rails to be at a constant distance from the curved walls. We couldn't connect to the walls, I forgot to say, because those curved zones of the walls are actually made out of fabric. It's like battylene fabric. So they had no structural strength whatsoever. And that's why we had to cantilever for about 6 meters from the hanging points, which you can see just about here. Obviously, when the rails deform, they the extremity sort of like bends away from the wall, and so we had to also work out what the pre-camber would be necessary, so that when they fell into place, when the rails moved into place under their own self weight plus the weight of the threads, obviously it was mostly their own self weight, we were able to, in the finished condition, achieve a constant gap between the rail and the fabric curved wall behind. So we managed to do that to Susanna's satisfaction with a tolerance of a few millimeters, so we were pretty proud of that. And this is again the hanging, and this was the first prototype, let's say 50 meters high. It's quite exciting, and there's a close-up of the rails on the right-hand side and the counterweight rails down at the bottom. And this was the effect that you had when you were walking through the piece. It was really rather magical, and there were some sound effects also that were in the arcades surrounding the area, which were able to intensify the mysterious experience of walking through these threads. So the piece was then bought by the Pompidou Center and became part of their permanent collection. And then the Louvre Abu Dhabi, once it had become part of the national collection, wanted to show it in Abu Dhabi. So last year, we were asked to look at how to hang it in a completely different gallery experience. And this is where I discovered about artist protocols, because Susanna didn't just ship the piece overseas, she completely redefined it for the new volume and the new context. So this gallery was actually rectangular. It was only 6 meters high from floor to ceiling, and it was surmounted by the mouche arabier of the rather magnificent building, which is the Louvre Abu Dhabi. For those of you who have the chance to travel there after COVID is over, it's a really wonderful building. Much better than I was expecting when I went to see it. I often say that. So the challenges were still how to suspend the rails. This was before obviously Susanna intervened. All of for her installation to be installed, all of the paintings were taken out, and this chandelier by Ai Weiwei was also removed. And we discovered also that strangely enough, although the building was very recent, it was very difficult to get access to decent drawings of what had been built in the ceiling. This ceiling was all made of glass, small pieces of glass, because it had a system where it could light up and fade. And the central part had shades which could be pulled over to block out all the light, or not, as the case may be. And Susanna wanted to use the natural light filtering through the mouche arabier. That was the inspiration. If I go back a stage to the reconfiguration of the rails in the top and bottom. And we weren't allowed, for warranty reasons, we weren't allowed to hang anything off the central zone because they had some problems with the functioning of the blinds. And if we hung anything from them, the people who they were attacking for non-functioning of the blinds could say, oh no, it's your fault because you hung something on it. So we then had to span 9 meters. Sorry, I'll go back. We had to span up to 9 meters across this empty space in the middle with the rails, and still have rails that were as small as possible. The second challenge we had was how to suspend the rails from what was inside this the glass ceiling. And this photograph is what was inside the glass ceiling. It was absolutely chock-a-block full of equipment and rails and finding, and we had to slide our suspension points through these very tiny gaps that you see here, 10 mil gaps between glass elements, and work out a way to hang them between. This was a test of where the thread would land, as we had to work out how we could hang off some of these aluminium strappings inside the structure without drilling through anything, again for warranty reasons. So this is a picture of the plan view. So that meant that all of Susanna's rails could only be suspended at points where they crossed with the longitudinal lines, which were the empty gaps between the glass panels, because in the line, the vertical, the other direction, the transverse direction, those lines were filled with air conditioning vents for the gallery. It was a very sophisticated ceiling, still is a very sophisticated ceiling. So finding suspension points were quite tricky, and then we had to build in 3-dimensional tolerance in each direction, because we didn't know whether obviously the rail positions had to be perfect, but where they would interact with the crossing points for the glass couldn't be completely predicted in advance, and what we would find inside to hang to couldn't be completely predicted in advance. So after having analyzed the determined the size of the rail that would hang the threads from, this was the analysis here. We had to work out how the elements could be prefabricated. This is a suspension system we came up with. So we hung, even though we were spanning up to 9 meters, we were able to get the structural element down to a 50 millimeters by 30 millimeters rectangular section. And the comb system that you saw in the previous model that Susanna used to connect the threads was connected on the underside, and then we had a cache around to to hide the technical bits, if you like. And then the 3 millimeter cables hung the rails back through the ceiling into the roof. So these were the adjustable bracket connections that we came up with, and this was everything that was hidden that we had to develop as a clamp system within the roof. So this is the cable coming through, and this is everything that you guys didn't see. So that's why I called this talk a disappearing act, because it's all about letting all that stuff, all our work, become invisible. And here are some views of the finished work. It feels quite different from the Nantes piece because of the proportions and because of the zigzagging of the rails. But I think you'll agree it's very hard to find the structure beyond that. Here's a suspension point, for example, and here's another suspension point. But we got them as discrete as possible, and Susanna was happy, and there was some rather lovely effects of the light coming through the mouche arabier into the space. There we go, that's my favorite photo. The next project I'd like to talk about was a really seminal one for me. It was again, it was a while back now. It was in 1998. Martin Francis contacted us when I was at RFR to say that he'd been asked by Frank Stella for some help in transforming an idea he had into a huge band shell, which would stand in front of a sports arena in Miami. So the concept was came from this form that he used to make a lot of different shapes. That's Frank Stella there on the left hand side. A Brazilian beach hat, which you can cut from a piece of paper. So it starts out as a developable surface, and then you twist it into crazy shapes, and it becomes a sculpture. He wanted this to become 15 meters high and become, well, called it a band shell, a sort of a space where people could congregate or have events. So we took, and it was for Miami, external environment. So wind loads of 600 pascals, which is about 4 times what we have in Europe. And we scanned the physical form which we'd been given from him, as you can see down here on the right hand side, with a digital pen, because in these days there wasn't any Rhino, there wasn't any Grasshopper. AutoCAD 3D was completely incapable of dealing with these type of curved forms, and MicroStation, which used the CATIA interface, had been developed initially for the aerospace and the naval industries, so was the only software, 3D software available that could deal with complex 3D forms. So Martin Francis, who worked with, used MicroStation, and so what we did, we used the technology available at the time and took a digital pen. We gridded up one of those Brazilian beach hats and created a cloud of points using a digital pen, which gave us 3D geometrical points in space every time there was every time we clicked it on the surface, and then we were able to rebuild from scratch the form in MicroStation, the form of the band shell. And then that was exported to our engineering finite element software. And these were the results of the analysis, pushing wind at it in various, the sculpture in various different directions. And as you can see, the conclusion was it deformed far too much. So we made a suggestion to reinforce the basic form with some trusses, and you could we thought that, I naively thought at the time that Frank Stella might be happy to hang the sculpture from a sort of external frame of trusses. Of course, he wasn't prepared to do that at all. He thought the trusses was a fantastic idea, but he thought trusses would be interested if they wove in and became part of the sculpture. So you can see, if you can see my mouse here, these are the trusses. So it came back, look, and these three here. So it came back looking like this, and I gulped, went a little bit pale, and thought, okay, so these are as inefficient as truss forms as one could hope to be. They're full of, you know, picking up bending moments, but it's very beautiful. So again, you see them here. So at this point, we left behind everything that was physical modeling, and the form of the sculpture continued to evolve directly in the virtual environment. And this was a real first at the time. We produced no drawings. There was no contractual drawings between. We then worked with a shipyard called CMN in Normandy, who were able to build the work for us. And we just transferred files from one team to the other. Stella's team did the cloud of points and interpreted the first form. Martin tidied up the form and added the trusses and manipulated the trusses for Stella, and extruded all the tubular elements around the edge. Sent it to us, we analyzed it in our finite element models, went back, changed the wall thicknesses, and defined the requirements for internal stiffeners. And then it got sent to the naval shipyard, who our files and Martin's files together got sent to the naval shipyard, where they imported everything into their version of CATIA, and they could where they could work out cutting patterns for each of the pieces and schedule the fabrication process. So these were our finite element models. And in the meantime, also Stella built a 3D, a third size model in fiberglass, which taught us a few things. We changed a few of the details and the proportions as a function of that. That's in his atelier in America. This was also happening digitally with modem software, modem internet connections, so the very slow connections, but we were again very rarely actually physically meeting up, but working across continents on this process. And these are photos of the different petals, the twisted elements. We called them petals. First of all, you had to build a jig on which the panels could be laid. And some of the jigs were really very complicated, as you see down bottom left. Each jig had to be built to a millimetric tolerance. We said to the CMN, you don't actually need to build millimetrically. You know, if the petals are a little bit 100 mil, 200 mil out of their theoreticals, it doesn't matter. It's fine for the artwork. And they said, no, we can't deal with that. It has to be millimetric precision. Otherwise, we don't know how to build it. So so they proceeded to make the piece in this very, very rigorous way. We had, because of the very strong wind loads, and because we were having to use a rather weak aluminium because of in order for it to be flexible enough, and we were welding it a lot, so we were working at aluminium at half the strength you can get for typical extruded sections. We had to have quite a lot of stiffeners inside the space. The transverse stiffeners were there to make the form, and the longitudinal stiffeners were there for the wind loading reasons, to avoid to increase the strength of the overall piece. These were the trusses. There were up to 80 people at a given time building the trusses. Again, those triangular elements that you see were just jigs. They were internal jigs rather than external jigs for being able to build the tubular forms. And the piece gradually went together. And we finally got to visit. That's me, bottom left. And it was a very strange experience being so used to seeing this shape at the size of a computer screen and all of a sudden being able to walk inside it. And this is Frank Steller on the left with the mayor of Cherbourg, who came to visit the sculpture before it got shipped. And what was really a revelation to me was the physical energy you felt when you were standing inside the piece. And I realized that this was something that Stella had always known would happen, this emotional response that you get to the sculpture, but it's something that we couldn't see coming until we were actually there looking at it. We were so preoccupied with the technical aspects of getting it built, dealing with some very complex intersections here, which had to withstand hurricane wind loads. And it was such a delight to actually step inside the space and realize the power of the artwork that we'd been helping to create. So there's some other photos of this. Was when it went outside. It ended up not being sent to Miami, and because Frank decided he was going to sell it more expensive than he'd initially planned to, because it cost him more to build than he'd initially thought. And so Miami said, no, well, in that case, we won't have it. So it sat for quite a long time as a rather incongruous element in the streets of, well, in the CMN's shipyard, but this is like a view from the streets of Cherbourg. And then last year it was shipped to an unknown location for a private collector that I don't know where it's gone, but that was you can see the people dealing with the shipping of it. And we had to, again, engineering wise, it was important to work out what was safe hoisting points, what we could develop as a temporary lifting platform on which the bandshell could be shipped across the ocean. Its official name is the Broken Jug, by the way. And then following on from that, Stella received the commission to build a major public artwork for the National Gallery of Art in Washington, D.C. So, sorry, that was the mock-up of it finally finished before it was shipped to Washington. And the first thing we had to do was work out a supporting structure to which Stella could throw an awful lot of stuff. He just wanted to throw stuff at it. And so we again had to be very flexible in our approach. This was, we built a tensegrity model of what we figured could be a structure. That's the artist assistant Ed Childress that was in the office in Paris. And we pushed and pulled at this and decided we were happy with its stability. Then we built a model of this is the structure. This is actually the engineering structure. You can see a lot of the pieces are floating. One of the amusing things we had to do was the members of each of these cigar trusses, each member was a different diameter, just to give more interest to the sculpture for no structural reason whatsoever. So again, we had to integrate that into the concept. We worked out a theoretical loading configuration that we then played with by throwing a few bandshells onto our model of the structure, because of course we couldn't model the stuff that he was going to throw at it because he didn't know yet. And then it went to Rhode Island and started being built, and fiberglass elements got added on, and stainless steel elements. And you can see in the middle here, this piece was, he had a bit of fun. He took some stainless steel, like 2 very thin sheets of stainless steel, inserted a valve onto one side of them, and then welded them together in random circular elements to make sort of like a Dalmatian formation, cut out holes around the welding lines, and then just blew it up like a balloon to get some of these strange forms. So there was also quite a lot of, so there you can see the stainless steel blown up. This is before the carbon fiber went on, but then elements of carbon fiber were added. You can see here. And here it stands to this day in front of the National Gallery of Art in Washington, cooking a snooker at the Capitol building. It must have had quite a Stella must have been quite pleased with it being there these last 4 years, because he wanted it to be a celebration of the chaos and unpredictability which characterizes the human condition. And it was certainly that as an experience, as an engineering experience, designing it to be safe for the public. On a completely different scale, the work we did with Thierry Videt and his son Jean-Sébastien turned out to be very useful in my day job as a facade engineer and structural engineer, because Thierry works exclusively with 50% perforated stainless steel. And here he wanted to develop from a previous idea he built without engineering help, but he liked the scale of the model, but when it translated to one-to-one, the perforated stainless steel got very floppy. So he asked me to have a look at it to identify the minimum number of connections that he could put in to, and the amount of curvature he needed in these conical sections. And these pieces here, in order to create this sort of diaphanous effect of is it there, isn't it there, that he was very experienced in creating for the pieces. But at a scale, these pieces were 9 meters long again. And we worked on a number of sculptures with him. One of this was a piece in Brussels, 8 meters high, so using a lot thicker material. So we had to do quite a lot of work on how to punch through 8 mil thick stainless steel without distorting it. Whereas when you're punching through 2 mil stainless steel, it's a lot easier. And also we had to integrate stiffness at the bases without destroying, and along the fold lines without destroying the basic concept of the sculpture. So you can see there's no apparent reinforcement there, but we did have to build in some slightly reinforced fold lines, which had to be perforated in exact synchronicity to make sure that the balance, the visual balance, and the light flow through the sculpture wasn't adversely affected. This was even more important on this sculpture, which was a 12-meter high column in Bois-Colombes in the Paris region. So for a new housing development, the promoter wanted to bring in some artwork into the space, and it was a very simple folded forms that were connected together. For which, again, we initially proposed along these folded edges. You could imagine, you know, structurally speaking, you put that into the machine and it tells you it's going to collapse. So we had to analyze it quite carefully to make sure that the folds were stiff enough to stay in place, and that the radius of curvature of the folds was good enough. And we suggested along the edges to add in little bars to that would stiffen the edges. But this was anathema to the artist, because all you saw, of course, then was the lines of the edges, and he didn't want that. He wanted it to be about surface, not edge. So we looked very carefully. Again, this was in the 8mm stainless steel, 50% perforated. What I learned was when you use 50% perforated metal, your eye cannot distinguish between what is the foreground and what is the background, and that's really interesting. It doesn't work at 45%, it doesn't work at 55%. The minute it's a non-equilibrated balance, your eye knows which is in front, which surface is in front. But when you have just one 50% perforated, your eye gets deceived into reading the background, the foreground as well as it reads the foreground, and it creates a much more interesting artistic experience. So here along the edges, you can see we did some modeling to work out how much of these edges would have actual material in contact, adjacent contact, rather than having holes in contact with material. And we worked out that about 1/3 of the length of each fold line could be welded up, and you can see that so where we could get in a bit of a weld, we got in a weld, a bit of a linear weld, and then otherwise we sort of we got some spot welds as far as possible, which had to be the same weld diameter as the thickness of the plate to make sure that it disappeared in the final element. So again, big relief when it worked. You can see here the sort of on this left-hand top edge an issue, you know, a good illustration of the issue we were dealing with here. And then we worked on a number of sculptures for the T3 tramway in Paris. The city had consecrated quite a generous budget for public artworks. This first one was with Langlands and Bell, a British couple of artists who are also interested in having people question the public environment. Okay, so it's a very strong interface with the architecture of the tramway. And the interesting thing that their concept was 2 sheets of glass either side of a frame on the 3 sides of each entrance, one of which, so here you have the general view. So one of which was screen printed with a vertical stripe, a 2mm wide vertical stripe, and one of which was printed at with the stripe orientated at 2 degrees to the vertical. And what that did was, so these were the angles. What you see on the screen is the angles at which the printing was carried out. But if you look at the this image here, you see that you get a moire effect, and the stripes on a given position, they change direction. So this picture was taken facing on this way, and the stripes look very horizontal. As you move around the sculpture, the stripes move with you and create a sort of a kinetic experience. So that kinetic experience was, I'll go back to this slide, was for during the daytime, where the screens aren't lit up. These were 5m by 3m screens. So they were very big at the time. Now it's become more commonplace to use big glass, but it was also a big concern for the RATP in terms of vandalism. How would they deal with rem placement if the glass was smashed, etc. If the glass was smashed, it mustn't fall into the hole of the, you know, the staircase hole or onto the streetscape. But the artist didn't want clamping pieces visible all the way around, so we had to work with them on a safe way of doing that. And at the night time, the experience was, as the tramway arrives, the color changes. It's blue when the tramway is arriving, red when the tramway is leaving, and white when the tramway is not in the area. So that's and each side you're seeing there's a tramway there on the left, because the other there are 4 of these elements, and the other 2 are currently in this image would be red or blue at the time. So it was a daytime nighttime sculpture, and very interesting in terms of the impact on the urban realm. For the T3 tramway, we also worked with Mark Hanford on the who's an American artist who did a lot of twisted lamp posts. Here's one in near Central Park in New York. But it was more of a challenge when we had to, again, this was 17 meters high at the Porte de Bagnolet in Paris. It's the main entrance off the Périphérique in Paris. And he wanted it to look like the lamppost had just been crushed and scrunched up into a knot, and then exploded into these light elements. So we had to make the connections here look as if they had failed structurally. Although we had to make them strong enough so that they didn't fail. So what we did was we made lengths of tube, we did crush them and plasticize them and bend them round, and then we put reinforcements inside them that would continue to function correctly, welded up the edges, and put everything together in the atelier so that when they brought it to site, there's a close-up on these falsely failed nodes, and this put together on site and then lifted up in one piece on site. Now, getting that through a checking authority is always quite a challenge, so we have to develop a protocol, a testing protocol, to show that everything's safe, and that although the steel's plastified, we've replaced an equivalent level of performance by welding up and adding some internal reinforcements. It was part reusing the metal, and it was part reinforcement. And the final project that we did for the T3 was for Sophie Cal and the Ponte Garigliano. I'll whiz through these quickly because I'm sure I'm running out of time. But this was she did with Frank Gehry. He scrunched up some pieces of paper and said, this is a sculpture, this would be great in some vibrant colors, etc. And this was, you know, a number of years after the band shells. So again, we were able to scan the form on the left-hand side and make a hard model rather than just a scrunched up paper model. That's on the left-hand side. We used that we made that in a 3D printer. And then we had to work out how, this is the finished sculptures on the right-hand side. We had to work out how we could create these scrunched up paper forms in a metalworking factory. And we decided the only way to, first of all, we negotiated on the forms themselves to make them a little bit more structurally sound. So we asked for them to be tipped up a little bit more so that in the initial conditions, so that when they fell into place under their own self-weight, they would still have an acceptable form for the artist. And then we scanned those resulting forms. We took them out of the computer and I identified them as individual petals again. They were hanging off the edge, the side of a bridge. And this is showing the interface with the foundations that we had to develop for the fridge. And we had to work out how to build them. We decided the only way to do this was by molding each piece. And so we had to make some molds. So we thought about different ways of making the molds and ended up making from various, successive slices of polystyrene, which we then, which the guys in the atelier then smoothed over with plaster of Paris to create a form, and that was used as a negative for forming small sheets of aluminium that were hot cast, and then in widths of about 1.5 meters to 1.5 meters, and then welded together. We had to weld them together in a zigzag form because you lose strength in aluminium when you weld it, unlike with steel. And so if it was all in one line, you'd have one weak line across, which would be more likely to fail than the rest. So if you do a zigzag line, you avoid that problem. And this was the inauguration day. The idea was that Sophie Cal would make random phone calls. It was a phone box, and she would make random phone calls and see if anybody picked up. It's now been dismantled and is awaiting reinstallation in another spot because sadly it was subject to vandalism. These public art sculptures are always at risk of that. You have to bear that in mind when you're designing. The final sculpture that I wanted to talk about was with Anselm Kiefer, which did very recently, again, a sculpture for the Rockefeller Center in New York. And this sculpture was a temporary exhibition for 4 months. Each year, the Public Art Fund in New York commissioned a sculptor or an artist to do something on this space. And on the right-hand side is Kiefer's initial sketch, and on the left-hand side is the finished work. So it was he wanted basically an inverted pendulum, a very large wing sculpture which could pick up made in lead, which is 1.5 times as heavy as steel. So a very, very heavy weight on the end of a pole. We came up with a thinner pole in the end, but he rather liked the idea of spreading it out. So the pole ended up a little bit thicker than in his initial concept, but it was still quite a challenge because if you imagine wind buffeting left hand, right hand on those wings, you can get quite a big torsional effect developed, and all of that had to be hidden within the wing structure and then the pole structure. So after having made his initial sketch, he then painted what he wanted to see. Again, already the pillar is wider here. And Anselm Kiefer, again, completely hands-on. He has a 33,000 square meter studio, which isn't, it actually was a depot for one of the big department stores in Paris that he purchased. And he paints day and night. And so he has a small team who build stuff with him, but he's extremely hands-on. So he built this at the full scale and said, this is what I want. We then built a half-scale model, as I say, all faced in lead. And he decided he wanted to, and we built we worked out a framework that could be hidden, that the guys in the atelier could then clad with the feathers. And then Anselm came along and decided to sort of throw lead books at the base. It's one of his motifs, and throw in a few snakes. And one of the key details was we had to work out how to transport this, because the wingspan's 12 meters, across the ocean to Rockefeller Center. And so we figured we had to make it in 2 parts, because it didn't fit in a container as it was. So the wings and the book were one part, and they had to slot into, you can see this connection here, slotted into the column and the base. And communication was quite, again, often a key challenge when I'm working on these sculptures, because artists aren't used to working with plans, and they certainly don't enjoy AutoCAD or Rhino, or they don't like looking at a computer screen at all. And well, the ones I work with anyway. And but so sketches and working with their hands is the key thing. So what they wanted to be built, this was basically the specification, the image in the middle, and this is basically all I had to work with. And the guys who were building with him didn't speak a word of French or English, so that was also another challenge. So you have to, again, drawing becomes a very important medium for communication. So we did manage to get some more classic engineering drawings done for this work, and then worked with Sochaux Knox on getting the subframe built for Kiefer. Then he went and tested, we printed it off at real size, and he tested it against his painted version and said, no, it needs to be a bit longer, this is more or less okay, this is too small, you've got to refine that, because I want it to be actually exactly like my painting. And so then the piece was built, all in stainless steel, because although it was only for 4 months, they knew they would be selling it on to private collectors later on. And so they wanted it to be able to last potentially 100 years. So we had to do the weld checking, make sure that safety was going to be fine for not only the Rockefeller environment, but also a potential other wind environment later on. We had to build in lifting lugs, this on the right hand side, to make sure that the craneage, there would be 1 night to install this at the Rockefeller Center. So the lifting had to go extremely smoothly. So everything had to be thought of in advance. And we have to do that because there's nobody else. So this was then the subframe got clad so that the feathers could be put on it, and we prepped the connection detail to the supporting column. This was how the feathers got built. Halfway built. This was the half scale model, but it was the same process for the full scale model, and it was checking all the time, Kiefer's team checking all the time against the spirit of the painted version, which was the inspiration. And then this is the mock-up built in his premises of what then got sent to America. And we were checking very, very carefully how to align the sculpture, because of these, if you recall, it's facing Fifth Avenue. If the alignment of the sculpture was slightly off, then the wings wouldn't be parallel to Fifth Avenue, and that would be a complete disaster. So we had to build in very carefully some adjustment, rotational adjustment for all the pieces. We also, at Fifth Avenue in parallel, had to work with the guys in New York without going there, of course. So again, it's all at distance, on a temporary foundation, because we weren't allowed to drill into the pavers at Fifth Avenue, so we had to build a temporary block. So that was the work on that. So we had to translate from metric into imperial. That was a bit of a challenge. We also had to get involved with the fabrication and shipping schedule. Again, normally it would be the contractor would be doing that, but there was nobody else. So we were doing it directly with Anselm's team, and he has a specialist shipper. So we spoke with them, worked out everything had to be there for the critical opening day, which was full moon on the 1st of May. And this was building in the rotational adjustment, checking everything in the atelier before it got shipped over, making sure that you could physically get your hands in into the space. You can see top right here. You can physically get your hands in to bolt up the pieces that we had actually thought about beforehand. So then they clad it over with lead before shipping, and that was the final installation of the piece in Rockefeller. So it was very exciting. I was very, very proud to go over and see it built at the inauguration. Most of the plinth is actually hollow, but there is a concrete base, and it's now part of a private collection somewhere in Texas. There's the artist with the sculpture, and luckily he was satisfied. Merritt, I don't know, there's one, I forgot, there's one more sculpture on this story, but maybe we've run out of time. What do you say?
Well, it'd be great if we could ask some questions, maybe.
Go ahead.
Because that's been fantastically interesting. And I was just going to say that it's beautiful what you don't see in these works, as you indicated at the beginning. And you know, it was very interesting to hear you talk about the you know, kind of your experience in working with architects and engineers. And I forgot to mention that you've worked with, you know, with Frank Gehry and with Morphosis and Sana, and, you know, kind of some very impressive range of architects as well as artists. And I think, you know, all of that goes to say that to do incredible artwork and incredible architecture, you need to work with incredible engineers, and I think that is what you definitely are. So thank you very much for that incredible talk.
There's a lot of us
sorry
about.
to.
A lot of us about. And some incredible
well, you know,
architects as well.
well, I also appreciate very much your the way that you're describing it, and one of the questions actually that Grania Hassett is asking, which I think is a really interesting question, and it was kind of going through my mind as I was listening to you describe, in particular, the details, and you know, when you start to see or give some insight into the level at which you're thinking about things from an engineering perspective. When you were talking about Susanne Fritzler's work, for example, and kind of spent a lot of time describing all of the stitching that happened in the Louvre Abu Dhabi above the ceiling, is really beautiful. And Grania, she was wondering what the smallest piece you've ever worked on is, or are there challenges that arise with these tiny little tiny little things? And I think, you know, when you were describing the work with Thierry Vide, and in particular this insight about the 50% perforated panels and those edges, kind of, for me, brought us very close to your thought process, and the level at which, you know, you need to analyze from an engineering perspective, analyze the kind of physics of what in fact is going on. But this question that Grania is asking is really about scale and finesse.
Yeah, and
if I understand correctly.
Maybe I'll just clarify the question. I mean, I found the talk amazing, Mitsu, and then I was just reflecting on one point on the fact that they all had span in common, or a scale in some way. And then that came down to your discussion about the scale of a material and the perforations, as Merritt has just.
We've lost you momentarily, Grania. Mitsu, do you want to come in?
I can, yeah, I can. I'll come back and I'll guess what you were going to ask, Grania. People only, I mean, you know, we have to get paid too, right? We don't do the work for free, and so often artistic budgets aren't, you know, are very limited. So an artist has to think quite hard before they bring in an engineer, and they bring in an engineer when they're really certain that we can add value and we can give them something that they can't achieve on their own. So working on very small sculptural pieces is rare. I do have a friend, a very talented sculptor called Paul Wallach, who I give free advice to quite regularly, because he works at the scale of 2 or 3 meters, you know, or even two or three, you know, or 20 or 30 centimeters sometimes on walls. And that's, but generally also sculptors are very autonomous at that intermediate, you know, small intermediate level. But where we come in is when they become big scale, and in particular when the public realm is involved, when public safety is involved and the client requires some justification. And then And we alternate between the big scale and the small scale because we're often filling big volumes with very small pieces. So when you're doing my day job as a structural engineer, I'm very rarely working with 2mm cables or, you know, or 4mm screws and things like that. But in the artworks, you know, the smaller you can get them, the better. And the other thing that's terribly important in artworks is tolerances. You know, you say, well, okay, we've got to be in like plus or minus 3mm here, and you think that's really good for a structural engineer, and they go, plus or minus 3mm, oh my goodness, I'm going to see the joint, you know. So you have to sort of find ways of being able to give them practically zero tolerance. And
That's fantastic.
so it's that scale really of the big and big to small that we work in.
And sorry, can I hold this for 2 seconds and just ask then, so the extension for me is, are there any unusual materials that you worked with? You know, I'm thinking like, I don't know, bread, steam, paper, you know, how does it ever fall outside of one's understanding into the difficult to calculate, you know, animal skin, these kinds of things?
For sculptures, generally, when you're working with these very experimental materials, it's not at a scale which is which is at risk for the public. So we can quite often get involved in that would come probably more in architecture than in art, because the artists would just do it. You know, they wouldn't be around waiting for us to give them some proofs. Often, I mean, the Stella sculpture for Washington, which had a lot of, you know, very unusual ways of using metal and then carbon fiber and things like that was interesting. But again, none of them were treated. They were treated as load, not as stabilizing element. But we tend to do more very unusual things with more common materials, and that in itself, you're stepping right outside of the codes.
For sure.
Yeah, and just
but I'll not say it.
Well, I just wanted to ask you also about, because you mentioned and brought up when you were describing your seminal work with Frank Stella on the broken jug, you were describing a little bit the, you know, the kind of technological challenges and discoveries that were made, you know, in that process. And I was thinking at the same time, because you had done work, you know, for example, with Frank Gehry on Louis Vuitton in Paris, and that the technology had by then moved on quite a bit. And I was just wondering, you know, in terms of because the Gehry sculpture is kind of incredible. And what I was wondering, and just thinking that the Stella sculpture is incredible. And before that, the Guggenheim in Bilbao had been made, I think around about the same time, maybe just finishing at the time that you started working on that, I don't know, but, you know, in the mid 90s. What has been the or have there been translations like that from, let's say, you know, when you're working on these kind of structural challenges in artwork that then have some kind of impact on either on architecture or on technology, on the computer systems, the software that, you know, is calculating these things? How has your work, I guess, had an impact in that way?
The work that we did artistically is very often been done in advance of being able to use it in the architectural, using the skills learned in the architectural environment. And the software is very often been playing catch up, partly because we can afford to be experimental with artwork. And we don't have the huge thing, you don't have a checking authority for artwork. It's just you, it's you and the artist guaranteeing it for the client. And, you know, you have to take that very seriously, but it does mean that you have more freedom. And so, you know, the compatibility between the software is only you have to guarantee it, and you can take shortcuts when you need to. And, but certainly, the arrival of Rhino and the arrival of scripting processes with Grasshopper has made it very easy to make these forms now, and the softwares can talk to each other in a much more straightforward way. Particularly, you know, parametric scripting has been a huge. We were already doing it in a primitive way for the Stella piece, but now things have moved on quite significantly. Also in terms of being able to physically make the forms be cost effective. The technology has caught up in terms of, you know, using you know, what kinds of jigs to use, being able to digitally program the laser cutting, you know, remote controlled robot operated laser cutting didn't exist. Okay, so now that becomes a lot more streamlined as a process, and therefore you can guarantee a budget better. But the techniques that we learned have been incredibly useful in helping architects who want to be at the forefront do what you know, showing yes it can be done. You know, that's it gave us that possibility to say that.
Yeah, it's kind of, yeah, I suppose it's kind of like the space program, the impact that the space program had on many technologies, for example. I mean, exactly. And I mean, at the same time, you know, working with, for example, you know, someone like Anselm Kiefer, who's not really driven by technology, just your kind of description of him always referring to the painting and the hand sketch and, you know, it's got to be like this. Do you feel like, or do you sense, you know, insofar as, you know, engineering has a kind of this kind of invisible expression that you've been describing, that those kinds of innovations are somewhat closed off by, you know, by technology, by the fact that the computer can make kind of calculations quite quickly that, you know, you used to have to labor over? Or are there, let me say, aspects of engineering artistry that still rest within the human mind, you know, that still require that kind of, you know, labored, let's call it, or laborious maybe calculations and kind of trying to figure out how to, you know, make something work or figure out how to get something. Has technology, you know, has it in some way superseded some of the artistry of engineering, or do you feel like in this work, particularly with architects and artists, are there areas that are kind of leading, you know, in new directions, where you're kind of still finding that artistry and, you know, going back to finding yourself with those, you know, sketch pads and pens and paper and cardboard and so on?
I think first of all, the challenge of all this parametric software and where it's so easy to make three-dimensional curves and change them and it's very easy for anybody to make what they consider to be a funky form or something like that. And so an awful lot of architects will do something freeform and think, hey, that's good, you know, that's it, stop there. And the difference between it's very difficult to make a really good freeform. And sculptors invest an awful lot of time and intellectual effort in understanding how very small changes in form can create greater impact in the volumetric experience, particularly when you're inside it. And I do feel that often that is underestimated by architects. Great architects who have, you know, amassed a lot of experience in building these forms can achieve wonderful three-dimensional experiences. You know, Gary does know how to do it. Ronchamp was the most, when I visited Ronchamp, it was so much better to be inside it than to see it in a picture. I mean, like these architects really know how to create forms as well as any sculptor. But so many forms seem to be fairly gratuitous, and I think that's an inevitability, but it's a shame. In terms of the engineering aspect of it, you can just pick up the form now and press the button and say analyze and load it up in a much more simple way. But that doesn't lead to optimization. It just leads to justification of a structure. And it's not it takes away the intelligence from the thought process. And you become those tasks can be robotized in the end, they can be automated. So where does our value come in thinking of a clever way to do things? And that's very much in the dialogue between it. So much of it is about communication before you just about talking and resolving issues before you get to doing the analysis. That's what creates a successful sculpture or a successful building as well. It's just as important in the realm of architecture, just understanding what the other person is trying to achieve in a very visceral way, so that you can react with appropriate proposals.
Yeah, it's very, I mean, this is very clear in your discussions, in your own, kind of personal interest in trying to figure out what's important. And
Yeah.
it looks like it takes quite a bit of like, if you just maybe to kind of, I don't know how much longer we can go on here, but I am interested in hearing about your own personal kind of experience of working on these projects. Like, what is it that you're particularly looking for or looking to get out of them? You kind of talked a lot about what the artist is trying to get out, and your own kind of description of, listening to that and trying to understand that. But at the same time, there's something, it sounds like anyway, there's something that's driving you in making these things work. And maybe it's around that insight that you described when you proposed making the big cage that would support the broken jug. But
I was young.
no, well, this is a very, it's at least for me, it's kind of insight into how you're thinking about how your thinking has influenced and informed the work, but also, I just wanted to hear a little bit about your own experience of working kind of within these sculptures.
I think it's lots of fun because you're not constrained by the codes and the standards. It's scary too, because you're not constrained by the code, you're not protected by the codes and the standards. So you're out there on your own, but it's you have to think very intensively and try and get to the essence of what the problem is, and that's immensely satisfying as a intellectual exercise, I suppose. So that's maybe part of it. It's, for me, what mainly drives it is, to be honest, it's the human interaction. It's the conversation between, and that's just as valid between an engineer and an architect as an engineer and an artist. The artist feels more vulnerable than an architect because they're quite, it's quite a scary thing bringing in an engineer, with the hat of technological knowledge, and they're very conscious that they don't operate in that domain, and so you're talking across a greater divide. But we both like to construct, so you find what the common language is. The common language is building. And you start talking about, how can we actually get this thing built? There's a huge satisfaction in architecture and in artworks into becoming invisible, because you don't want your work to be, oh, that's where the engineer had to intervene. You want your work to be just the work, and it to be part of the texture and the experience of the piece. So what you did, but you don't want anybody else to be able to identify what you did. You want to be subsumed into the whole, and then you can be really proud you've achieved something. That's where you don't know where one person stopped and the next person started, because in reality we don't know that.
That's wonderful description, actually, that last 2 minutes of discussion. Jer Carty of Grafton Architects says hello. And
hi, Jer, how are you?
I think you're speaking to, he wanted to ask, and we're going to quickly pull in his question just to wrap up, which was related to what you were just talking about, Mitsu, about how you feel about the participation in works with a sculptor as opposed to an architect. Is there the same level of, sharing the goal, so to speak? Yeah,
I guess on one level you feel even more of a sense of responsibility when you're working with an artist, because you're such a small group. It's you're never surrounded by you're very rarely surrounded by a team. I mean, most of these pieces I didn't do on my own. Some of them I did, but most of them I didn't. But nevertheless, you're a very, very small number of people around, and you really feel, it's what I come back to at the beginning there. There's a huge passion and intensity in in the drive, because they're putting their own necks on the line in a much more extreme way than an architect does when they're building these pieces very often. it's their entire being which is being put on the line with each piece, and that can be true for architects, and that generally creates the most intense buildings as well. But the number of people that are required to build a building and design a building is generally significantly bigger, and that tends to a little bit dilute the experience. So for me, it's always about getting down to the core of who can have that conversation that will drive the concepts through. And when you've found how those of you who are interested in having the conversation as much as need to have it, can speak with each other, that tends to make things happen.